this lesson, we will be solving proportions. Proportions are a type of equations. We'll be solving them and then using some applications. Our guiding question, what is a proportion? A proportion is an equation that states that two ratios are equal. Equation stating that two ratios are equal. And as you know from the last lesson, a ratio is a fraction. Okay, so a proportion states that two fractions are equal. Our enduring math skill will be practice standard 8. Look for and express regularity and repeated reasoning. And how will we do this? You're going to master the cross products property of a proportion. You will use this as a shortcut to solve proportions, and you'll see structure and general methods in repeated calculations. So now we'll go ahead and we'll look at our definition of proportion. Our definition of proportion, as we stated earlier, is an equation stating that two ratios are equal. If two ratios are equal and a quantity in one of the ratios is unknown, we can write and solve a proportion to find that unknown quantity. And that unknown that we're talking about is a variable. We can solve a proportion in two different ways. The first way uses the multiplication property of equality, and we have already done that when we solved equations. And the second way is the cross products property. We will look at an example of each. So if we look at our first problem 1 here, it's solving a proportion using the multiplication property. If we look at our problem, 7/8 equals m divided by 12. We're solving for m, so that means I want to get the m by itself. And so using our multiplication property, since that side says m divided by 12, the opposite of dividing would be multiplying. So if I multiplied each side of the equation by 12, that allows the 12s to cancel out there, because I have 12 divided by 12 would equal 1. And then I'd have 12 times 7/8. And I get 10.5, and if I put that in a fraction, I get 21 halves. So m would equal 21 halves. So that's solving a proportion using the multiplication property. Now the cross products property of a proportion says that the cross products of a proportion are equal. So if we look here, we have our A times D will equal our B times C. So we take the left diagonal and multiply it, and then that will be equal to our right diagonal. So for example, if we have 3/4 equal 9/12, if we take our left diagonal, we have 3 times 12, which equals 36. And that's going to equal the product of our right diagonal, 4 times 9, which is also 36. And now here we have an explanation as to why it works. If we look, It says assume the equation's true. We use the multiplication property of equality to get rid of our denominators, multiplying both sides by BD, which would be our common denominator. And then we end up with our AD equals BC. In the proportion, A and D are what we call the extremes of the proportion, and B and C are what we call the means. So the product of the means equals the product of the extremes. If we look at problem 2 here, we're going to solve using our cross products. So I'm going to multiply my left diagonal or my extremes, and I get 4 times x, which is 4x, equals the product of my means, or my right diagonal, 3 times 8, which would be 24. Then I would divide both sides by 4, and I would get x equals 6. And you could put it back in your equation and do your check. Now we have a multi-step proportion. It works the same way, except I have a quantity as my numerator. Since I have a quantity, I need to put parentheses around the quantity, and then I'll go ahead and I'll do my cross products. I'll multiply my left diagonal, and I'd have 4 times b minus 8 equals, then I'd multiply my right diagonal, and I'd have 5 times b plus 3. Then I just go ahead and solve. I do my distributive property. 4 times b is 4b. 4 times negative 8 is negative 32, so I'd have minus 32 equals 5 times b is 5b, and 5 times 3 is 15. I would subtract my 4b from both sides, and I get negative 32 equals b plus 15 minus 15 from both sides, and I get b equals negative 47. And I could substitute it back into my equation, and I would see that I am right. Now we can model a real world situation with a proportion. We just have to make sure that we write the proportion carefully. You have to write the proportion so that the numerators have the same units and the denominators have the same units. So if we look down here, a correct way to write it, you see that you have your miles on both sides here at the top, and you have your hours on both in your denominator. Incorrectly, you have the miles and the hours across from each other in the numerator, and hours and miles across from each other in the denominator. That's not what we want. We want it to be the same as it is over here. So let's look at an example of a problem. It says a portable media player has 2 gigabytes of storage and can hold about 500 songs. A similar but larger media player has 80 gigabytes of storage. So how many songs can the larger media player hold? So I'm talking about media player and the 2 gigabytes of storage and holding a certain number of songs. So I could write a proportion, and I could say the first one has 2 gigabytes of storage and it can hold 500 songs. So I have gigabytes on the top, songs on the bottom. So it says the larger media player then has 80 gigabytes of storage. So I'll put the 80 gigabytes up here on top because that's what's on top on my ratio on the left side. And what I don't know is how many songs that it'll be able to hold. So now I can do my cross products, and I can do my 2 times my x, which is 2x. And I can do my 500 times my 80. And I get 40,000. And then divide both sides by 2 to get the x by itself. And I get x equals 20,000. So to answer the question, how many songs can the larger media player hold? It can hold 20,000 songs. So when I have a proportion and I know 3 out of the 4 parts of the proportion, I can always solve for that last part.